All right, so we're into Module 3, which deals with principal component analysis. So we'll go ahead and jump right in. So it's all about PCA. You guessed it. So the basic idea here is around kind of reducing dimensionality to some extent. So, and you'll learn how to do PCA in multiple programming languages and interpret the results of a PCA model. So what is it? And it's about reducing the number of features, as I mentioned, the dimensionality, the number of variables that are being used in a model. And so it lets you focus on those things that have the most impact to the results of the model. But it's not without its problems, right? Because in doing so, you may inadvertently exclude something that is important. But it sometimes is necessary. You usually use the principal components that have an eigenvalue that is greater than 1, and we'll talk about that in a little bit. And then a lot of times you'll use a scree plot to plot the eigenvalues. So how do you do it? So it's kind of just pretty straightforward, right? To step 1, you read your data and select the variables that will be used in your PCA. Then you want to standardize the variables so that they're on the same ranges, basically. And then calculate the PCA vectors. Then you'll use some eigenvectors or eigenvalues and other approaches as a scree plot there to figure out how many you need. And then you use the PCA to then score your data. So let's go ahead and hop into that. I don't know if I want to trust the link, so we'll just switch windows. Maybe I should trust the link. It's not that one. Oh yeah, it was that one. So I'll make that a little bit bigger, probably a little small. It's not too bad. So hopefully you can see it okay, and hopefully I'm actually sharing this time. So
Yep.
it's always that. All right, so we start off with our typical sort of approach, NumPy pandas. Probably have that in almost every notebook you do. Sometimes you probably have it even if you're not using it. And then from sklearn you pull in the standard scalar and PCA. So we pull that in. This is code I've mentioned, I think, in the past that basically handles the fact that I sometimes use the Linux subsystem inside of Windows. Sometimes I run it natively inside of Windows, and sometimes I'm on my desktop, and sometimes I'm on a laptop. So basically, nothing magic here other than I take a look at the platform, figure out if it's Linux or not. If it's Linux, I check to see if this path exists. If it doesn't, then it must be this one, because I'm
Cool.
not that complicated. Otherwise, you just pull out the expand the user's home directory, and then the whole point of that is so I don't have to mash up this directory every time. And of course, it's not going to work. What I do not import OS. So, yeah. That's nice.
Cool.
So you can see this is actually running inside of the Linux subsystem for Windows. Let me show you that briefly. I don't know if you're familiar with it. Stop me. But basically, what WSL2 is, and it's the second version of it, it's one of the two, is it's a form of virtualization, really. And what it lets you do is have a full-fledged version of Linux running inside of Windows without having to run something like Hyper-V or VirtualBox.
Wow.
And so the cool part, it's easy to set up for one. And then also, once you've got it set up, you can go into Microsoft Store and search for the flavor that you like of Linux. So if you look for, I probably don't like the 2. Let's get rid of the 2. And look for WSL. You can see here Ubuntu and various other versions of it, right? And it's as
Very
easy,
cool.
after you've turned it on, set it up, it's as easy as just installing it, and then all of a sudden you have it available to you. I'm using Windows Terminal here, which lets you do tabbed, essentially command prompts, right? So
Yep.
I can open up a command prompt and switch. This is actually the Linux prompt. That's a bash shell.
Huh.
So the reason you do that is sometimes things don't work quite right in that are coming from a Linux world that running on a Windows machine. And in fact, you'll find a lot of projects now say that it's like an implementation of something for Linux that runs on Windows. They say this is deprecated because we're going to use WSL2 instead, right? So
Oh
um,
wow.
yeah, it's and the last it sounds like I work for these folks, right? But the last thing that's kind of cool is you can actually from inside of this Linux shell, I'm running what's basically going to be Visual Studio Code, and it has to do this one time of installing a little server to do the proxying back and forth. But once it finishes, you can actually use a real editor inside of a Linux environment rather than having to do, I don't know, whatever old things they have, right? So, and here's that instance, right? I didn't particularly, I don't think I've got any kind of files there, but that came up. So if I were, a better example is code, what is it, dot bash, dot something, what is it? It's the one you always have to, oh, I'm not in my,
Is it bash profile?
yeah, but I'm not in my, I think it's that, right? Um, that should open somewhere. Where did it go?
This is cool. So this is a virtual machine that's running on Windows,
Yeah,
and you're connecting to it for your terminal.
but it's yeah, but it's integrated in. It is using virtualization under the covers, but you don't have to do anything to make it happen. You basically go into um, what is it? Install or uninstall is probably the better way to find it. Where you know how you turn your features on and off, right?
Mm-hmm, mm-hmm.
And you basically can just turn it on. So I think it's here. So apps and features, um, and I'm running. It's a buggy version of. Come on, there we go. So you go into here. I'm running Windows 11 beta, and this particular build is not good.
Okay.
So anyway, so you go into here and you look for Windows Subsystem for Linux, and just check the box.
Jeez.
And then once you do, it turns it on. If you want to, you can actually do stuff like GPU pass-through if you are doing something that's interesting inside of it. But if you just want to get it up and running, it's that easy. You turn it on, and all of a sudden you can have, and not just a single instance. I can actually download like 18, Ubuntu 18, and run it concurrently. And you can even have multiple instances of the same Linux distribution, so I could have another copy of 20 running if I was so inclined. It's a little clunky, but you can do it. You have to do an export and import. But anyway, the nice thing with it is that you can run Jupyter and all of the other stuff, and you're running them kind of firsthand, and I think it's a little better performance. It seems like it to me.
Okay.
So anyway, that's the reason I do it, is that it that, and once I get an environment set up, it's a little easier to kind of persist it if you really want to, because you can do backups and restores and stuff.
Yeah,
So
that's really cool. I'm using a Mac, so I'm on OS 10,
yeah,
but I've got parallel software for Windows. I'm going to check that out.
yeah,
When I need Unix type capability, I just go to OS 10's command line. But
yeah. If
uh,
you're a Mac person, you're already pretty much there. But if you're Windows and you want to do Linux stuff, you either have to, fire up a VM or something else. And this is it's a lighter weight way of doing it, and it's better integration into the OS. You can actually, from File Explorer here, if I scroll down to the very bottom, you can see a Linux tab, and I can
huh.
actually go to that file system if
Oh,
I'm
that's cool.
right without, because I mean, I don't know if you've used things like VirtualBox and
Yep,
Hyper-V. It's always painful to cross that line, right? To go
sure
from
is.
operating
Like one
system.
folder is typically what I'm used to
Yeah,
using as the Rosetta Stone.
yeah. And with this, the line, it gets really, you stop thinking about what's where. So the fact that over in this bash shell, This is
Mm-hmm.
actually my Windows file system that I'm accessing, but I'm accessing it through a mount point that it takes care of for you. So whenever you log in, it mounts your local drives as C and D, in this case because I got a D drive, right?
Yep.
So you don't even have to do anything, and it by default kind of drops you into your home directory as the user you're logged in as, right? So uh, very cool and very
Slick. Yeah.
yeah, seamless experience. And you can even run, not that there's a real compelling reason to do it, but you can run Linux GUI applications this way as well. So you can actually, I might have one installed, I don't know. It's more of a a novelty versus being productive, right?
Yeah.
'Cause
I kind of like it though. I like to have X load up.
yeah,
I have an X Motif emulator on my Mac that I use to host, um, the X11 environment.
I was thinking I had one, but I don't see it. But yeah, that was one of the things they rolled out was WSL2. They call it WSL2G for graphic, right? So you can actually
Hmm.
run graphic applications inside of it, and they're leveraging some sort of or like whatever it was, the compatibility stuff. It's been around for a long time, but it actually works now. So it's kind of cool. Anyway, I digress a lot.
Yeah.
But PCA is not all that complicated in a lot of ways, so we can do that. So your first step is to go through, you read it in, and then figure out what columns you care about, and that's what's going on here, right? So we narrow it down to loan, expense rate, years in business, and a few other things, right? So pretty straightforward. Then usually you poke around a little bit to see what they look like, right? And then it's pretty straightforward here of doing a standard scalar with the fit transform, turning that into a standardized, looks like centered on zero, or yeah, it looks like centered on zero and roughly the same scale. And then basically figure out what's the shape. I probably should pull that out as a separate, so we can print it. So there's 7, and that hopefully corresponds to 7 up here, or the ones we picked. I think it was 7. That's a few more than 7. So 7. Anyway, so we figure out what the max n is, and then you say that that's how many to do. So in this case, we're going to look for at most 7 components, and then it does the fit. Then you can get out the eigen values, so the explained variance. And you're supposed to use ones at, what was it, greater than 1 as a general rule, so you would probably use those 3. The last 4 probably not. And then a scree plot, which I think I read something in the documentation. They were in the course room that it was hard to do in R, but it didn't seem that hard. So I'll show you that in a minute. So the basic idea here again is to just kind of plot it so you can figure out roughly where things are at. Similar, not that dissimilar, I guess, in some ways, like an elbow plot, right?
Hmm.
Similar concept. Then basically can figure out the components and what that looks like, and then basically you can use this the principal component to do the scoring of the new data. So I think that's the last step. And that's pretty much it. So with that, I'll switch back here. And then we can take a look at it in R. Actually, I'm going to have to bragging on bragging on the Windows subsystem and my preference for it. But one thing you can't do is run. Let me open this up. I'm switching over to the Windows machine because you can't run that SAS emulator or work-alike in a Jupyter notebook on a Linux machine. because they consider it to be a server environment. So because
Okay.
you can't really differentiate between Linux desktop versus Linux server, right? It's kind of Linux is Linux. So all I'm doing here is just opening up a notebook on the Windows machine, but because I was able to install it here, not there.
Right.
So, yeah. Should have thought of that ahead of time. So down into here. Go ahead and do the R one next. And I tried to follow the same sort of pattern, repeating it so that it is stepwise. And some of these things happen automatically, but not necessarily here. Similar code to what I did before, so it's figuring out where's my home, and then adding that to it. So loaded in the file, the same file, which is kind of cool. I think that the course designers picked like Bizloan and ran it through several of the modules. It's kind of nice to see it from
For sure.
different perspectives. Sometimes it's so many different types of data that you kind of don't really get to know the data. And here, once you figure it out, then it's kind of cool. Same sort of thing. 1, 2, 3, 4, 5, 6, 7. Yeah, I thought there was 7. I don't know what I was looking at a minute ago. So 7 features. And then the same sort of splitting out just to those. Take a look at the 7. Yep, looking good. Standardize the vector. I don't think we have to do that here. I think it takes care of it for you. So hence the magic. And so here you just calculate the PCA and take a look at it.
But scale equals true is what says that step, right?
Oh yeah, you're right. Yeah, that's it. Yep.
That's nice.
Yeah.
I love R.
It's one of those. A part of me kind of like to not like it, but it's just so easy, right? To get things to do things. It's like literally like one line of code versus how much was that other one, right?
Exactly. And my thing is, I love R when I'm doing interactive analysis.
Yeah.
But as far as coding, Python blows it away.
Oh yeah. I really want to. I want to find a way to run Rust into this one as well, because it's like fast Python, right? Is the way to think of it. Python's it's it adds it gets rid of the tabbing by adding the squigglies from like C# and Java, right? So your scoping is clean, but it's also compiled, right? So a lot faster. Anyway,
Wow.
so that's a scree plot, right? So I don't quite I don't understand, because I read something that acted like you couldn't hardly do it, and it's
Well, the comment that confused me in the course material, it was a minor thing.
Yeah.
It made it sound like R automatically does the scree plot for you while Python doesn't. I'm like, well, there are a million ways to do this plot in Python.
Maybe that was it. Yeah, it was one of those that it's like you couldn't do it, and it's like, well, yeah, you can do it. It just
right.
It's a line plot. I mean,
I'm sure that we can figure this out.
well, and especially Google, scree and then whatever language, and you'll probably find it because it's not a common word, right? So,
Right.
Anyway, so I'll stop ranting. And then similar sort of concept here. We take a look at the values. Go ahead and run it again just to make sure, and then. On down to there, and then we basically are to our last step of predicting and using them, right? So we can figure out what it is that they're producing. The part of this that, to be honest, I thought for some reason I had in my mind whenever you hear the name principal component analysis, and this is something that I figured out over quite a while back. But anyway, when I first read it, I thought it would tell me what's the principal component, right? So I could actually feature analysis is what I thought it was meaning, but yeah, no, that's not it, right? So anyway, I digress again. All right, and then and our good friend SAS, which anyway, hopefully it works since I actually restarted everything just to make it. I tried I did some in the online environment, and I don't like it. I just don't.
Yeah, I'm with you. There's something about it that bugs me worse than the virtual machine that we were using before.
Yeah,
I tried to sign up for this, and they were like, "No, pound sand. It can't do it for you.
yeah,
Yankee, go home." So
yeah.
whatever. You know, I'm pretty much sticking to R and Python anyway so far. So
When I mean, I think this is probably in a similar. Um, Once you were to learn it and you used it a lot, you would probably get to that same sort of devotion, right? So that, well, it's just so easy. I just type in one command. Uh, I get hung up.
especially in this case,
Yeah,
the
yeah,
examples really made that clear.
yeah.
Yeah, it almost tempted me to do it, but I'm not gonna.
Well, and it does some pretty. This granted, this is the WPS thing, but it's essentially the same thing. But it did make
Right.
it pretty easy to do this. This is produced all this with literally that, right? So,
It's very
um,
cool.
yeah, I mean, I could appreciate, again, it's about if you had it installed, and that's going to be another challenge. Is it's going to be a whole lot easier to get R or SAS or R or Python through some sort of procurement process than it is to get a SAS license, right? So,
Right?
but
That's true.
if you had it, then yeah, this is pretty cool because it's a
Yeah, it
nice
is.
little report, and yeah, I can see it.
Yep.
And in fact, the correlation matrix, that's nice. Yeah, that's eigen
Hmm.
values Yeah, that's definitely. I mean, I'm sure you can do the same thing in SAS and R, but not
Hmm.
that easy, right?
Yeah.
So,
Yeah, you
uh,
can tell they've done this before.
yeah. Oops, that died, so I can close that. Yeah, well, and it's definitely, well, you can tell the guys that wrote this, they literally probably had two computers, one with the SAS software running and the one they were developing to produce it, right? So,
Yep.
uh, uh, which used to be okay, but somehow SAS fought that one off. So, recommended reading. There's several books out there on PCA, and several websites. I think this one was pretty good because it was like come on, are you not gonna? Maybe if I hit the right button, it'll do it. Here we go. Where you go? Okay. I think it was one of these did some nice. Yeah, it was this one, I think. Some nice sort of showing you the point of what you're trying to do
Hmm.
is literally reduce the dimensionality, and then showing it again of going out of this into this, right? So um, there's several good resources out there around it. So kind of cool, um, kind of useful as well.
Yeah, that was like a website.
Yeah, yeah, yeah. There's several of them out there where they I think this also talked about eigenvectors and values, which kind of cool. If you
Very cool.
Yeah, if you want to learn more on them, but it's know what it kind of means versus where did it come from. Two different
Hmm.
things, right? So anyway,
Right.
deliverable 3. You guessed it. You're going to use PCA on some loan data. So basically, here the rubrics how we get graded is always, and you're now a data scientist at Frostbite Falls Bank. Don't you want to
Mm.
move there? Your
How
bank.
appropriate.
It's probably in Minnesota, right? Your
Okay.
bank.
Yes. As a matter of fact.
It is it really? Yeah.
Yeah, according to the canon of Rocky and Bullwinkle, it's Frostbite Falls, Minnesota.
Yeah.
Hmm.
My whenever I joined the company I work with now, my first assignment was in Fargo, North Dakota, in January.
Poor
So,
thing. Yeah. Are you okay?
yeah, it was. Of
That could
course,
be hard.
I wondered who I upset to get that gig, but anyway, you just think you know what cold is, right?
Yep.
So basically, here, same sort of thing. You've collected a large amount of data and so on about people paying their bills and forfeiting on loans and blah blah blah. So now you're going to be using PCA to figure out what variables make it the best projection. So that's that. So again, multiple languages, so SAS and Python most likely. Develop a regression model to predict the probability of default using PCA. And then a subset of the PCA components and justify your choice. So pick probably those that I'm guessing are greater than 1 for the eigenvector value. And then print the coefficients and then describe them and then comment on whether or not PCA makes sense for this particular assignment. And then text file or textual representation of your source code in each of the languages, and Word document with screenshots justifying it, and which is also probably the memo. 1 document there. It's not, doesn't have to be 2. Just like what we've been doing, works great. And describe what PCA, if it makes sense, and how it works, and so on. And that's basically it. Shoot for the mastery as always. Multiple languages, well written, screenshots, clear, provide a full understanding of and accurate output, and then thorough description of how the number of PCA or principal components is to use is and the analysis was determined, and then clearer and thorough description of each PCA chosen, or PC I guess it would be chosen, and a description of whether they make sense intuitively. So does it seem rational? So one other thing I wanted to show, let's see, where did I do that? Me being me, I thought throw in something different. Where did it go? Too many. Let me find it. I think it was here. And so I took the code. Let me find it here. I'm going into my Azure subscription and to Databricks. And I uploaded, because one of the things you can do with Databricks is import Jupyter notebooks. And I pulled it in. I'll go ahead and try to kick off a cluster just so we can see it. Shouldn't need very much. I'll do that one. While that's spinning up. And essentially converted it to try to do it inside of Spark, right? So Databricks is hosted Spark essentially. Make that
awesome.
A bit bigger. So I took the notebook, imported the same one that we just went through. In Python, I'm using the Python language. You can Databricks will support. It'll actually support R too. I don't know if it does it natively at a notebook level. Yeah, it does. So you can write in well, I'll show you. Python, R, SQL, and Scala. So basically the Jupyter cells, it's very similar to Jupyter, but the cells, you can also switch languages per cell, right? So you tell it this is the default language, and then so everything in here is going to be Python, but if for some reason I want to write some SQL, and in this case you basically could just add a cell. You got to do it at the very first thing, but you basically say something like SQL, and then you can just write SQL, right? Whatever. And what I did was
crazy.
I imported the data into as it makes it really easy once the cluster comes up. I'll show you. But you can go in here. Actually, I can just and you drop it literally right here, right? So you take your CSV, drop it on that. It'll walk you through the process of, and I can show that too, I guess, rather than just, wrong class. So if I wanted to do that other one, it'll probably stop me until that cluster comes up. But you basically can say, I want to upload this file. And then you can say I want to create it with either a UI or a notebook. I'm going to say notebook because the cluster is not up and we can keep going. And so here it basically auto-generates all the code you need. So during that, it dropped it into this location inside of the Databricks file system. You tell it the type of file, you tell it if you want to infer the schema, you probably do, and tell it if the first row is the header, which most of the time it is. And then it basically, the rest of this code will read that file at this location of this type, so it's a CSV file, setting these values into a data frame. Spark data frames are very close to Panda's data frame, except they're based on a RDD, a resilient distributed data set, so that you can run them across a cluster at huge scale, right? So it's pretty powerful stuff. So we load it into a data frame, then you can give it a name, get rid of that CSV, and it'll create essentially a temporary view called that, and then you can make that view a permanent view by going through here and essentially changing the permanent table name to be something like that. Parquet is the default file format most of the time it uses. There's also a Delta format, which is a bit more exciting. Pretty cool stuff. So once my cluster comes up, I can run that. Looks like it's up. So it's a similar pattern to a Jupyter Notebook, right? You just do Shift Enter on each one of the cells, submits it to the Spark cluster, and you saw how easy that was to get that cluster up and running.
Yeah.
You can go through and provision a cluster in literally like a few clicks. You give it a name, you say what kind of cluster you want it to be. Standard is basically a cluster for a person. High concurrency is a cluster for a bunch of different people. Single node is a cluster that's just one machine, so that you don't have to. It's cheaper is why you do it. So if you leave it with that, you can basically pick the runtime, determine if you want to have auto scaling turned on. So if it reaches capacity, it can increase the size from somewhere between 2 and 8 workers, or you can turn it off and say you want to be fixed priced or fixed size. You can pick the processing power that you're interested in. So it's a trade-off measured in DBU units or DBU, which is a unit. So that's what the U is. It's a Databricks unit, and they can get quite expensive, especially when you get into some of these down here that have GPU acceleration built in. But if you need it, it's there. And also pretty powerful machines. Some of these, it's not liking it because of the runtime I've got running. There's also an ML runtime that has pretty much all of your typical machine learning libraries loaded up. So PyTorch, TensorFlow, all that kind of stuff is already in there. You don't have to do any configuration. Graph Frames is in there as well, and lots of other stuff. So it's literally that easy, and then you click on create and it creates it. And then when you're done with it, you can delete it. So it's if you've ever stood up a Spark cluster or a Hadoop cluster, it's a world of difference, right? It's just literally click, 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 and it's done.
Yeah, it sure is.
All right, so go ahead and run this, and just to show what that's doing, and it's creating basically nothing really complicated. It's reading this file into a data frame. It's turning that data frame into a temporary view. You can then select it using SQL, and this is where we're seeing this is a Python notebook with SQL embedded. There's a little bit of trickiness there, because if you want to traverse between cells or between languages, you have to do so through something like either a temporary view or a table. A variable that exists in this context can exist in a different context, because it gets confused, right? So if you have a Scala variable, you can't access it from Python directly. You have to go through some sort of a temporary view or something to do that. But still, pretty powerful stuff, right?
Yeah, very cool.
And doing all that, it has a nice little tab over here where you can go see your tables. Here's the one I just created. And you can either delete it or you can take a quick look at it from just what does it look like, and it samples the data.
Is the memory scope cross-language environment? So if I set a variable of the same name in memory with Scala, can I reference that same variable in Python?
No, you can get across that boundary, but it doesn't work natively.
Okay.
You have to either send it to, generally the way you do that is going through a temporary view. So you basically create you take a data frame, turn it into a temporary view, and then you can access it from there.
And the view then is effectively in memory, whether or not it is or not.
Yeah,
It
yeah.
is effectively in memory. Okay.
Well, and that's what's weird with in memory with Spark is an interesting question, right? Because at the point I do this right here, so I'm taking it, I'm literally converting that CSV or that table that I created from a CSV back into a data frame, right? I could have read the the CSV directly, but this is kind of an interesting way of doing it, and this is closer to what you do whenever you're actually doing this for real, right? Because you create tables. Generally, those tables are backed by a data lake, so that they can change. Data can be ingested, and you don't have to do anything to access it. When you run your query, it does the latest. At the point we did this, nothing really happened, and all we did was essentially build the plan of what we want to happen when we actually realize it. So it's it's a lazy evaluation is what it is.
Yes. Yep.
So this data frame there's nothing really in it. It kind of knows what it's supposed to look like. It has a plan of how to construct it, but it hasn't actually done it yet. You can take a look at the table by doing this is Spark SQL. It's essentially SQL it's close to like maybe MySQL, that flavor, but it's pretty much everything you need is there. Plus you can do streaming and a bunch of other stuff, but that's different. So it does do some cool stuff where you can do visualizations kind of just natively. That's not a very interesting plot, but so whatever key would be. Anyway, so you can basically do simple visualizations pretty quickly. So maybe a histogram would be a better.
Mm-hmm.
Oh, well, that one actually worked, did it? Whatever
Yeah.
it was, bar chart, that kind of works. Here in business, late payments, yeah, that works. So you can see simple analytics. It's not not necessarily anything it's not going to put Tableau out of business, but it's for doing it quickly. So at the point I actually do this display, it's actually going to gather this information. I'm not actually doing anything with this one yet, but it's actually going to go out and make it become real. It's going to essentially collect it across, if it's spread across the cluster or if it has workers have to do it. That one's not very interesting because there's not a whole lot of data. Typical sort of stuff similar to, you've got a head function where you can take a look at the first, n records. And then here, this is where it got a little more interesting because there is PySpark has ML machine learning libraries capabilities. It took me a little bit to figure this one out, but it does have a standard scaler, and I believe this is pretty close. I didn't get 100% done with this, but I went through, basically did the standard scaler. You had to do a vector assembler first to get it to work because you had to like convert them from the data frame to a vector and then do the transformation and blah blah blah. Anyway, so at this point it's still, we're not really doing much yet because we're taking it and we've got this the standardized data frame, but you can see it took a little bit of time, but most of that time was figuring out what to do. It didn't actually do it yet. Now at the point we do this, it actually goes and does it. And it's still pretty quick. Probably it's taken advantage of the fact that it did some work up here. And then now you can actually calculate the PCA. There is inside of the feature namespace, instead of the PySpark ML, there is a PCA. And so you can run it. And this is where I got to. I think the next one is where I haven't finished. I was trying to figure out how to get the eigenvectors out of this because it didn't seem to surface them. So that's where I got to, but you can see not that far away from being done inside of PySpark, right? So kind of cool.
Yeah, very cool. And that functional programming is a whole different beast. You've got to think about the Lambda functions like you're looking at below, and
that's
it's less fun of an environment for me to work in personally, but I have done it.
You got to change the way you think about it, right? You move away from iteration to the lambdas, and I think what this problem, I think I figured out, even though I stole this code. I didn't write this code. I stole it from here, right?
Okay.
But they say it's for a data frame, but I think I think it's really an underlying thing called an RDD, which is a resilient distributed data set. Data frames in Spark replaced it, or they're built on top of it, and they're built on top of it because RDDs are kind of hard. I bet that's what it's missing. Is that right there? Here. Yeah, maybe not. Or maybe that plus some more.
I think you're on the right track.
Yeah,
It's going to be something like that. It almost always is.
Well, that's what I think the issue here is that a data frame, whenever you do a select off of a data frame, you get back a data frame, right? So we're subsetting the columns we care about, but data frames don't know about map, and map is how you do your lambda function, right?
Yep.
So that'll probably do it right there, actually. Maybe. Optimism. Yep, there we are. Look at that.
It was cool.
Almost like I knew what I was doing, right? But anyway, so
yeah, well, you can find your way through it by feel, right? You gotta do exactly what you did there with the trial and error. But yeah,
well, and that's where the
hierarchy software really helps.
Yeah, and that's where the kind of the point here to take away is, whenever you get into doing some analysis at scale where you're dealing with truly large amounts of data, the transition isn't that horrible when you've got those foundations in place to go to something like Spark and doing it at that scale. There's also koalas it's a very similar sort of thing as to pandas. But
God, these names kill me.
Yeah, well, I think that's a purposeful sort of. Yeah, it's like a a panda, but it's a koala. Anyway, but it's not 100% compatible with pandas, so it's pretty close. I kind of look at it, if I'm going to go that, I might as well go to a data frame, right, if I'm going to have to deal with something different. So anyway, so I guess with that, we can shift back. I think that's pretty much everything. As always, thanks for joining. Eric, if you have any questions after you watch this, let me know. That's what I'm here for. Stay safe, and we'll talk again on Monday.
Sounds great.
All right.
I'd like to run one thing by you.
Sure.
If you don't mind, just something that was kind of bugging me on the video when they describe how what looks like a least squares regression line, right, rotated to the horizontal, and then you take your first principal component as the distance from the y-axis to that. I mean, this all looks a lot like another way of using the least squares thinking, because second principal component is the error, right? And I think that where PCA really becomes very useful is when we have multiple dimensions beyond 4, because you can envision, right? You can envision, height, width, depth, even time as different snapshots of those. But when you get beyond 4 dimensions, it's really tough.
Yeah.
And it seems like that's the power of this methodology. That's really how it all kind of that's the underpinnings of it, right? That's really
and it's the high dimensionality it's kind of a reoccurring theme, right? That's the same reason that you do some of these other things, is because you're dealing with potentially exponential growth, right? So each time you add another variable, it becomes
just out there,
I
don't know how to envision it.
Yeah.
And when I read like Tibershani and Hasty, and they reference the hyperplane, is that what they're talking about? The place that you can't envision but is there, and the math can describe it in ways we can't see.
Right. An n-dimensional plane is basically a hyperplane. Is essentially that. Yes, it's
got it.
It's a construct of. Okay, just like a plane can intersect 3 dimensions, right? A hyperplane could intersect in whatever, n minus 3 dimensions or something, whatever it is.
Sure.
Yeah.
Okay, cool. And then the other thing that was sticking with me was, it's clear that eigenvalues greater than 1 should be included in the model that you'd build. There's also a fuzzy area, kind of an art and science type, thing, which we're all used to in this field, where you need to use judgment for the 0.9s, the 0.8s.
Right.
And what was interesting is in the example, the first principal component had let's say 0.5-ish values, but across the board there were like 4 of the 7. And that was the strongest predictive power component. The next one kind of filled a gap where the first principal component didn't have strong coefficients, the second one did, and then the third one again had a different one still. And it seems like that's another way of figuring out how to rationalize which components to include or not is this component adding unique value to the whole?
Yeah.
So then I wanted to like crossfoot, sum them horizontally and find out where the variation kind of tails off.
Yeah.
Which is what a chart does, right? Isn't that what the scree chart does?
Yeah, pretty much. Yeah, that's yeah. You're pretty much getting it. The part of it, you're right. It's almost to me. It's reminiscent of things like an ensemble method, right? Where the combination of things is stronger than the individual one, right? So it's a similar sort of concept. And whenever you're doing this, probably in the real world, you'll most likely be doing some sort of auto ML anyway. So you'll determine what's your success criteria, and then you'll run it through probably thousands of different algorithms, right, at the click of a button. And then you'll figure out which one of those did the best across the board. Right? And you do similar things by potentially doing iteration across, if you're saying, well, how many components is the right number of components? You might treat it as a black box test, right, and do a split of your train and test and run it through and see which one does the best, right?
Yeah, and what you just said flipped on the switch for the light bulb that says you could use Monte Carlo selection to help out with this too, and multiple iterations of it.
Yep.
Check the overall agreement. Very cool.
Yep.
Okay. Thanks.
Yeah, it all well, and there's patterns you'll start seeing within the concepts, and they all kind of leverage off of each other over time. So
Sure do. Yeah, and I've been recognizing these things in some way, shape, or form since I realized that support vector machines work in a way that's not dissimilar from a more complex implementation of least squares regression, right?
Yeah.
You're expanding this thing as wide as you can to separate the two classes. And again, when you get into multiple dimensions, that hyperplane that they always talk about, or the n-dimensional plane, this has finally made that light go on. So appreciate it.
Oh, sure thing. Yep.
Very cool.
And as always, any questions, feel free to reach out.
You got it.
That's what I'm here. All right.
All right.
Thanks
Have a
again
great
for
weekend.
joining. Yep. You too.
Sir.
Yep. Goodbye.
See you later. Bye.